Hello everyone, thank you for stopping by. My name is Bino, and in this video we will determine the following Laplace transforms without the use of the table. Instead, we are going to use this first principle formula in order for us to determine the Laplace transform. So why do we use the Laplace transform? Suppose we have a bulky mattress that's hard to move. Instead of struggling to carry it as it is, we use a vacuum bag and compress it into a smaller, more manageable size. Once you reach your destination, you remove it from the bag and it returns to its original form. The Laplace transform works the same way. It compresses complex time-domain functions into simpler S-domain functions, making them easier to handle and solve. After solving, you use the inverse Laplace transform to return to the original time domain function. So just like compressing and decompressing the mattress, the Laplace transform simplifies and then restores our mathematical functions. For our first question, we have to determine the Laplace transform of e raised to the power 4t using the first principle. So let's reintroduce again the formula for first principle. So we have the Laplace of the function f of t, which is equal the integral of e raised to the power negative st multiplied by the function f of t, and our integral is with respect to t, and it's from 0 to infinity. And in our case, this will be equal the integral of e raised to the power negative st multiplied by the f of t, which is the e raised to the power 4t, and we are integrating with respect to t and from 0 to infinity. So let's first simplify before we can integrate. So we have the integral, and we can see that the e and the e, we have the same base, so we add the exponents. So we have e raised to the power negative st plus the positive 4t dt, and our integral is from 0 to infinity. And we simplify further, this will be equal the integral from 0 to infinity of e, and we can see that the t and the t are common, so we can take the t as our common factor. So we have the t into negative s plus 4 dt, and from here we are at liberty to integrate, and the integral of e raised to the power t into negative s plus 4 will be equals to e raised to the power t into negative s plus 4 divided by the negative s plus 4, and our limit is from 0 to infinity. And from here we have to substitute our limits, but we cannot substitute the infinity directly, so we look for the limit of the e raised to the power t into negative s plus 4 divided by the negative s plus 4 as the t approaches infinity. In order to ensure convergency, the s must be greater than 4, and if the s is greater than 4, the part which is inside the parenthesis will always be negative. So if that part is always negative, then our limit will be equals to 0. And from here, let's evaluate on the other side our limit when the t is equals to 0. So we have to substitute the 0, so we have e raised to the power t into negative s plus 4 divided by the negative s plus 4. So we substitute 0 directly where there is t. So we have e raised to the power 0 into negative s plus 4 divided by the negative s plus 4, and 0 multiplied by the negative s plus 4 will be equals to 0, and e raised to the power 0 will be equals to 1, and this is divided by the negative s plus 4. Now that we have our results of the limits at both 0 and infinity, we can now go and substitute, and this will be equals to the result of the infinity, which is 0, minus the result at 0, which was 1, divided by the negative s plus 4. And from here, this will be equals to, so let's distribute the negative to the denominator, and the result will be equals to 1 divided by positive s minus 4. And this will be our answer for the first question. For our second question, let's reintroduce the formula for determining the Laplace transform using the first principle. So we have the Laplace of f of t, which will be equals to the integral of e raised to the power negative st multiplied by the f of t and dt, and we are integrating from 0 to infinity. In evaluating this Laplace transform, we can use f of t to be equals to the cos 4t. However, this will require us to use integration by parts twice. Alternatively, we can express cos 4t using Euler's formula, and cos of 4t using the Euler's formula will be equals to the e raised to the power I multiplied by the 4t plus e raised to the power negative I multiplied by the 4t, and we are dividing this by 2. And this will be equals to the f of t. So we have the integral of e raised to the power negative st multiplied by our f of t, which we expressed as e raised to the power positive I multiplied by 4t plus the e raised to the power negative I multiplied by the 4t, and we are dividing by the 2, and we are integrating with respect to t from 0 to infinity. So we can distribute the e raised to the power negative st inside the parentheses, and our integral will be equals to the integral from 0 to infinity of e raised to the power negative st multiplied by the e raised to the power I multiplied by the 4t plus the e raised to the power negative st multiplied by the e raised to the power negative I multiplied by the 4t, and this is divided by 2, and we are integrating with respect to t. So from here we have the same base both sides of the plus sign, and then if we have the same base, then we can add the exponents, and this will be equal to the integral. But before that, we can take that 1 over 2 out of the integral. So we have 1 over 2 multiplied by the integral from 0 to infinity of e raised to the power. So since the bases are the same, we add the exponents. So we have the negative st plus I multiplied by the 4t plus the e raised to the power negative st minus I multiplied by the 4t. And we are integrating with respect to t, and in both situations where there is the e, we can see that the t is common, so we are going to take the t as our common factor. So we have 1 over 2 multiplied by the integral from 0 to infinity of the e raised to the power t, which we take out as our common factor, into a negative s plus I multiplied by plus the e raised to the power t into negative s minus I multiplied by the 4. And we are integrating with respect to t. And from here, we can let I multiplied by the 4 to be equals to a, and this will be equals to 1 over 2 multiplied by the integral from 0 to infinity of the e raised to the power t into negative s plus a plus e raised to the power t into negative s minus a in the place of I multiplied by 4, and we are integrating with respect to t. So from here we can integrate. So this will be equals to the 1 over 2 multiplied by the integral of e raised to the power t into negative s plus a, which will be equals to e raised to the power t into negative s plus a, and this is divided by the negative s plus a plus the integral of e raised to the power t into negative s minus a, and which will be equals to the e raised to the power t into negative s minus a divided by the negative s minus a, and our limits we have 0 to infinity. We are now going to evaluate our limits at infinity and 0, but for now we are going to omit the half. We start by evaluating the limit at infinity, and we start with the first term, and then later on we evaluate the limit at infinity for our second term. So we have the limit at t as it approaches infinity. So we have the limit of the first term, the e raised to the power t into negative s plus a divided by the negative s plus a as the t approaches infinity. In order to ensure convergency, then the s must be greater than a, because the part which is inside the parenthesis must be less than 0, and if that's the case, our limit will be equals to 0. And on the other side, we evaluate the limit of the second term, the e raised to the power t into negative s minus a divided by the negative s minus a as our t approaches infinity. And in this case, in order for us to ensure convergency, then the s must be greater than negative a, because the part which is inside the parenthesis, the negative s minus a, must be less than 0. So that part must be less than 0, and if that's the case, then our limit will be equals to 0. And from here we evaluate the limit at t is equals to 0. So let's copy and paste the result of our integral, and once again we omit the 1 divided by 2 for now. We substitute 0 directly where there is t. We have e raised to the power 0 into negative s plus a. This is divided by the negative s plus a plus e raised to the power 0 in the place of t into negative s minus a divided by the negative s minus a. The 0 multiplied by the negative s plus a will be equals to 0, and e raised to the power 0 will be equals to 1. This is divided by the negative s plus a plus 0 multiplied by the negative s minus a will be 0, and e raised to the power 0 will be equals to 1. So we have 1 divided by the negative s minus a. From here we copy so that we can paste this later. And this will be equals to, so now we can include our half. So we have 1 over 2 multiplied by the result of the infinity was 0 minus the result of the 0. We copy and paste it, and this will be into parentheses, and we have the 1 over 2 into, so now we distribute the negative inside the parentheses, but we distribute it to the denominator, and same applies, we distribute it to that denominator, and this will be equal to 1 divided by positive s minus a plus 1 divided by positive s plus a and from here let's simplify. We have 1 over 2 into, so we use this little triangle, and we have the denominator multiplied by the denominator, so we have the s minus a multiplied by the s plus a, and we have that denominator multiplied by that numerator, which is 1, and we keep the sign, so we have 1 multiplied by the s minus a, and that denominator multiplied by that numerator, it will be equals to the s plus a multiplied by 1, which will be equals to the s plus a. And from here, further simplification, we have 1 over 2 into, so we can see that the s plus that s will be equals to 2s, and the a minus a will be 0, and this will be divided by the s minus a multiplied by the s plus a, and from here that 2 and that 2 will cancel out, and it will be worth realizing that in the denominator we have a difference of 2 squared, so this will be equals to the s divided by the s squared minus the a squared, since we have a difference of 2 squares. Remember that our a was equals to, so the a was equals to I multiplied by 4. So we go right ahead and substitute 4 multiplied by I, where there is a, so we have negative. In the place of the a, we substitute 4 multiplied by I, and this will be squared because the a is squared, and this will be equals to the s divided by the s squared minus the 4 squared, which is equals to 16, and the I squared. Remember that I is equals to the square root of -1, so we have the s divided by the s squared minus 16 multiplied by the I squared. So let's square the I. So I squared is equals to the square root of -1, which is equals to -1. So that -1, we multiply it with the 16, but then the negative multiplied by that negative will be positive, and this will be our answer for this second question. For our last question, we don't have to introduce the first principle, so we have the integral of e raised to the power -st multiplied by our f of t. In this case, we have the t as our f of t, and we are integrating with respect to t from 0 to infinity. So as we can see, we have to use integration by parts to evaluate this. So the formula is the integral of u multiplied by dv, which is equals to the u multiplied by the v minus the integral of v multiplied by the du. So this part corresponds with our integral. So what I'm saying is this integral is equals to the u multiplied by the dv. So between the u and the dv, one of the function is equals to e raised to the power -st, and the other function is equals to t, and we deploy the Euler rule to help us determine which function will be equals to u and which one will be equals to dv. So the I stands for the inverse trigonometric function, whereas the L stands for the logarithmic function, and the A stands for the algebraic function, and the T stands for the trigonometric function, and the E stands for the exponential function. So the e raised to the power -st is an exponential function represented by the letter e, so that letter e on the Euler rule, and the t is an algebraic function represented by the letter a. Going to the right, the first letter that we come across will represent the function that will be equals to the u, and the other letter will represent the function that will be equals to the dv. So as we can see, we have the a before the e, so the a represents the function that will be equals to u. So we have that t which will be equals to u, and the dv will be equals to the e raised to the power negative st. In the formula for integration by parts, we have the du, and to get the du we have to differentiate the u, so the derivative of that t is equals to 1, and inside the formula for the integration by parts we have v, and in order for us to get the v we integrate the dv. So the integral of e raised to the power negative st will be equals to e raised to the power negative st divided by the negative s. And so the integral of the e raised to the power negative st multiplied by the t dt, and our integral is from 0 to infinity. This will be equals to the u multiplied by the v, and we have that u multiplied by the v. The u is equals to t, and the v is equals to the e raised to the power negative st divided by negative s, and our integral is from 0 to infinity, and we have the minus the integral of v multiplied by du, and our v is equals to the e raised to the power negative st divided by the negative s. That negative and that negative will be positive, and our du will be equals to 1, and we are integrating with respect to t from 0 to infinity. So this will be equals to the t multiplied by the e raised to the power negative st divided by the negative, with our limit from 0 to infinity, and we have that 1 over s multiplied by the integral of e raised to the power negative st, which is e raised to the power negative st divided by the negative s, and our limit is from 0 to infinity. From here, let's try to simplify before we can substitute the limits. So we have t raised to the power negative st divided by the negative s, plus that plus and that negative will be negative, and we have negative, and that 1 over s multiplied by that 1 over s will be equals to 1 over s squared multiplied by e raised to the power negative st from 0 to infinity. From here, let's substitute our limits, but we cannot substitute the infinity directly. Instead, we look for the limit of the t multiplied by the negative st divided by the negative s minus 1 divided by the s squared multiplied by the e raised to the power negative st, and this limit is determined at t as it approaches infinity, the first limit, which is the infinity, and this will be equals to, so in both cases the e raised to the power negative st, we take it from the numerator to the denominator, and the exponent is going to change sign from e raised to the power negative st to e raised to the power st. On the first term, if it's not obvious, we can use the L'Hopital rule by inspection to see that the limit will approach 0, and for the second term, if the e raised to the power st is in the denominator, then this will be equals to 0. Let's now evaluate our limit when the t is equals to 0. So we go right ahead and substitute t for 0. So we'll have 0 multiplied by the e raised to the power negative s into 0 divided by the negative s minus 1 divided by the s squared multiplied by the e raised to the power negative s multiplied by the 0. And this will be equals to, so on the first term, 0 multiplied by any number will be 0. We have the negative, so that negative s multiplied by that 0 will be 0, and e raised to the power 0 will be 1. So we have 1 divided by the s squared, and this will be equals to negative 1 divided by the s squared. So from here we can substitute. So we have the first limit of infinity was equals to that 0 minus the second limit of the 0, which we calculated as negative 1 divided by the s squared. So we have the negative 1 divided by the s squared, and the negative multiplied by that negative will be positive, and we'll be left with 1 divided by s squared as our answer. Thank you guys for watching up until this point. If you have any questions, do leave them in the comment section below. Remember to subscribe, like and share.